In this episode, I will be discussing sound isolation, sound transmission class. This is Noise Engineers podcast, brought to you by Noise Engineers, an independent acoustical consulting firm. I'm Bill Holliday. Thank you for joining me on this episode. I'm going to touch on a few issues we deal with regularly. This is a big part of our work, is sound isolation. That could be between spaces or from outside to inside, because it could be inside to outside, but normally we're dealing with exterior noises into a room. These generally, we use a rating system. It's called the sound transmission class, and it's a single number that rates the sound isolation or the amount of noise that a partition will attenuate. That sound transmission class is generally for speech, so you have to be careful. If you have bass noise or aircraft noise, it's not always going to work, or you have to be just aware that that number might not be appropriate. Generally, a sound transmission class of 50 to 55 is pretty good speech privacy. Above that, of course, even better. Below that, you're probably going to hear something between the rooms. So we use, sometimes we're dealing with requirements. There are many city requirements. We deal with San Diego quite a bit, where they say, hey, the noise inside can't be more than 45 decibels, a pretty low average day-night level. And so if you're in a flight path of aircraft or near a highway, they have to do a noise study and just make sure that the exterior construction will reduce the noise down to those levels. Sometimes we measure what the existing levels are from aircraft and roads, but more often than not, we're just using predictions. The airports have these noise contours, and we can just locate where that building's going to be or that home's going to be, and we can say, you're in the day-night level 70 noise contour, so we need to reduce the noise by 25 from exterior to interior. And so we look at the windows, the doors, the wall construction, and we come up with a noise attenuation. We use a program, it's called INSOL, that helps us with these predictions. It can determine just what the noise reduction is by octave band or third octave band, so by frequencies. So it gives you this STC number, but it'll also give you the frequency noise reduction. And that program will determine what the STC is for, or the sound transmission, for different constructions. So you can put in, here's a gypboard face, here's the studs, there's insulation, we're using resilient channels or staggered studs, and then here's the exterior face, and here's your reduction. Then you can put in a noise source through the program or apart, just what's the spectrum or what kind of noise are you dealing with, and then what are you going to receive on the other side. ASHRAE, it's for Association for Heating, Air Conditioning, Ventilation Engineers. They have tables of what's an acceptable background noise level. So you can kind of work backwards. Here's acceptable, here's what they have, figure out what wall construction makes sense, or given whatever wall construction, you can determine if there's going to be issues. So we look at exterior to interior to fulfill requirements from cities or counties. We look at room-to-room sound isolation. We have a law office right now we're working with, and that's what we have to determine is what are the paths of the noise. It could be the wall, could be a window, could be a door, could be the air conditioning system. Maybe the ventilation system is connected, and so noise is going, there's an easy, unattenuated path from one space to another through the ventilation system. So we look, noise works a lot like water or light. Any gaps really hurt your attenuation. So when you're calculating the composite STC, or the transmission loss of a system that has multiple components, the weak link really hurts you a lot. So if you have a window, I mean, you can think of this normally. If you have an open window in a wall, that wall could be block concrete, 3 feet thick. But if you have an open window, the noise in that space is going to be not attenuated very much from the outside to the inside. So we look at each component, each path. We can determine how much is coming from each path. And then you usually are attenuating or attacking the weakest link first. A lot of that depends on costs and what the goals are, but that's usually the case. So a lot of times for these homes, it's the window construction is the worst. Sometimes doors are an issue if there's a door near a noise-sensitive area. But doors generally, if there is a door, the seals are a big issue. Weight of the door, those will all be issues. So we can measure the sound transmission class as well by playing or putting a loudspeaker, a broadband noise source, which just means a noise source that's generating energy in all different frequencies of concern. We call it pink noise or white noise, broadband noise, kind of like the static on a radio or TV. Blast that in one room, the source room. You can measure the levels in that room and then go over and measure the levels in the receiving room. And you can determine how much noise is being reduced by that partition. We also, when the sound generator is off, measure the background noise level to make sure the background noise isn't influencing our measurement. And then we do a reverberation time or an echoiness test in the receiving room to get a standardized number. Because if you're receiving noise in a kitchen or a bathroom compared to receiving noise in a bedroom or living room that has more absorption, we really are just trying to test that component. So it'll be louder in an echoier room than in a quieter room, a more absorptive room. And we want to get a standard number for what's the sound transmission of this floor ceiling system or of this wall system, not what's the noise reduction just in general between these spaces. I mean, sometimes we care about that, but it depends on the case. But if we're trying to determine what's the sound transmission of this partition, of this floor ceiling system, then we want to normalize it or take out get a standard room absorption. So we just correct it. It's an easy formula to correct for the absorption of the room to get a standard room. One other thing we look at is impact insulation. So when you're looking at a floor ceiling system, the airborne noise, someone talking, that's going to be sound transmission. It's from this noise turning into vibration, turning into noise in the receiving area. The other issue we deal with a lot for floor ceiling systems is impact insulation, and that's for people walking in heels, clicking along on the floor. Of course, if they have a carpet, that improves it a lot. If it's a hard floor, it's going to be transmit a lot easier. And there's a tapping machine, a standardized tapping machine, and it actually drops weights, a standard distance, a standard frequency, a standard weight of those weights. It sounds kind of like a ba-ba-ba-ba-ba-ba-ba-ba, sort of a machine gun type sound that you just put up in the source room, measure, and you can come up with an impact insulation for the space, a standardized number, and compare that. The best thing for sound transmission and for impact insulation, the best thing you can do is separate the two sides, the wall on one side or the ceiling on one side and the floor on the other or the wall on the other. The more space, the better. If you can physically separate them, that improves greatly the sound transmission and impact insulation. So separating it would mean using staggered studs where they share base plates, or dual studs where there's a physical break between the studs, two sets of studs, usually have like a 1-inch gap between them. You can also use things like resilient channels Or there's also other resilient mounts. There can even be spring isolators for a ceiling system that you can mount the ceiling on. And that just really isolates one side from another, so the noise or vibration impacting one side has to go through the spring isolator or has to convert to noise or sound and then convert back to vibration. And that break greatly improves the sound transmission class or the impact insulation class. Adding fiberglass or mineral wool or some kind of spray-in absorption can improve. You have to make sure it's an absorptive spray-on treatment, but can improve the sound isolation as well. It doesn't do as much for impact insulation, but for sound isolation, adding absorption improves it. The more mass you have on those outer layers, the better. Doubling the mass on one side will generally improve the sound isolation by 3 points. 3 decibel more reduction. You get diminishing returns, so doubling it, going from 1 to 2 is a 3 reduction, going from 2 to 4 is a 3 reduction, going from 4 to 8 is another 3. So another system that you can use is constrained layer dampening. There's several companies that provide this. It's gypsum board with kind of sandwiched with this kind of like a green glue, or a kind of, it's kind of like an Elmer's glue that doesn't harden, a non-hardening, resilient dampening material, which actually they say 1 inch layer of this, which is kind of the sandwiched material, is equal to 8 layers of gypsum board. So it can save, it's costly, but it can save space is primarily what it would be used for. Other absorption, of course, for floor ceilings, you could treat the ceiling, isolating it on spring hangers or resilient channels, increasing the mass. You could also treat the floor. You can float the floor, which would mean putting a rubber or squishy, they have even fiberglass, but a squishy layer and then your hard layer on top of that. Kind of putting it on springs, that's another option. It gets costly and it can add height to a floor, so it's usually something to be considered ahead of time. But we do look at that, especially for like a gym. We've had condo units where there's a gymnasium above residential units. All right, I think that's it for this episode. Thank you for listening to the Noise Engineers podcast. Let me know if you have any questions, comments. You can get to me through noiseengineers.com or Facebook, Twitter, LinkedIn, any of those, or put a comment here. If you like these podcasts, please leave a rating and comment with iTunes. All right, thanks a lot.